All right, problem number 22 is really asking you guys to think outside the box and looking something that you've probably never seen before. And to be honest with you, I had never seen before either before looking at this problem. It's something called intercept form. And the equation for it, this is kind of the eventual target that we're looking for here, is this equation right over here. X over A plus, oh, I just realized I wrote that wrong. That should be a y over b. Glad I caught that before I got too far here. Y over b should be equal to 1. I'm going to double check that, make sure I wrote that correctly. Yeah, now I have it there. So what they're asking you to do here is show, in fact, let me read this directly, that if A and B are not equal to 0, meaning then your x-intercept and your y-intercept, neither one of those could pass through the origin right there, then the line with an x-intercept of A and a y-intercept of B can be shown to have this equation right over here. Now, I'll bet a lot of you looked at this problem and had absolutely no idea where to get started. So my advice to you then in a case like this, start with something you know. If we take a look at this equation right here and this line that we have there in red, what I see is that this line here has a y-intercept of b, and I should be able to figure out the slope as well. So I'm going to go to what we know well, slope-intercept form. Y is equal to mx plus b, and I'm going to fill in both the slope and the y-intercept based on this graph. So the slope here, let me go to red here for just a second, let's calculate that. If we were starting at this point right here and ending at this second point, we usually like to move from left to right, my rise then means I'm actually going to drop down b units, and then I'm going to run a units to the right. So the slope of this line is negative b over A. Again, this problem is asking you to do some abstract reasoning, and we really have to hit hard the fundamental concept that A and B are numbers here. They're just arbitrary numbers whose values are going to change from problem to problem. So I know that the slope of this line is negative B over A. So let me go back to my equation here in blue. Y is equal to, and that slope is negative B over A multiplied by x. And then we're going to add to that our y-intercept. And where does this line cross the y-axis? Right here. So this is a little odd. So the y-intercept is whatever the number b is. So it's going to feel like we didn't actually make a substitution there, but what this problem is kind of trying to illustrate to you guys is where the convention in math comes from that we let our y-intercept equal b. And I have a strong hunch that it's because the x-intercept was initially called a. So what we have in blue right here, guys, is the equation of this red line right over here, the line that we're talking about, in slope-intercept form. All right, so now that's the equation in a form that we're comfortable with. They now want us to show that as long as A and B are not 0, we can take this form and algebraically manipulate it and get it to turn into this form here. So that's a skill you guys have had some practice with over the years here, but this one's a little bit different. So let's see how we can go from this equation to this form right over here. Well, the first thing I notice is that like standard form, the equation that I'm going for here has x and y on the left side and the constant on the right. So what I'm going to do is take this x term here from the right and bring it over to the left. And that's now going to be a positive b over a times x plus y, and all of that is going to equal b. So now I'm at least in the right format of what I was looking here. X term plus y term is equal to a constant. The other big thing I noticed, though, is that the right side of this equation should just be 1. So how do I turn a b into a 1? I'm going to divide every term in this equation by b. And this is where it becomes important that they set in the directions here that b is not equal to 0. If b were equal to 0, I couldn't do what I'm doing right here. I wouldn't be able to divide by 0. They also said in the directions a was not equal to 0. That's what makes it okay to have an a down there in that denominator. Okay. So where does this get us? The right side of the equation, let me start there. B divided by b is just going to be 1. This middle term, y divided by b, can't be simplified at all. Okay, so I've got that. And now this one here is just a little bit messy, but what's going to happen, guys, is that the b in the numerator and this b in the denominator are going to cancel each other out. So I now have a 1 over a times x, which could otherwise be written as x over a, and we would add that to the y over b, and it would equal 1. And that is what the book is calling intercept form. So we started with something we knew, which was slope-intercept form. We figured out what the slope was and what the y-intercept was and came up with this equation here. And then we just did some algebraic manipulation and eventually got it down to this. So hey guys, this problem is done. But just real quick, if I were to give you an equation, then something of the form, let me go with x over 3, how about minus, just to be interesting, y over 2 is equal to 1. What they're telling us now is that this particular line here, because it's in intercept form, has an a value or an x-intercept of 3. So I would go 3 units to the right and put a dot right there. My y-intercept would be this number down here, except for the fact that this is supposed to be a plus sign, but I actually have a minus. So that means my y-intercept is -2. And with those 2 points determined now, there's only one unique line that passes through both of them, and it would look something like this. And just for fun then, I'm just trying to map this out here, guys. If I followed my slope, I'd get to another point over here, which I believe is going to be 6, 2. Let's just check real quick and see if that's right. If I put a 6 right here for x, that becomes a 6 over 3, which of course is 2. Minus my y coordinate here, 2, goes right there. 2 over 2, that should equal 1. Well, 6 over 3 is 2. 2 over 2 is 1, and last I checked, 2 minus 1 is equal to 1. So testing that one point here, 6, 2, and seeing that it worked doesn't guarantee that this is right, but if I did this a few more times, I think you guys would feel pretty good about that. Okay, so that's number 22. Not a problem you should have known how to do, not a problem you're going to do a whole lot with in the future, just kind of one of those cool ones where you look at it and go, oh, that's kind of neat, and I didn't know you could write the equation of a line like that.